Hello dear students, welcome to the another video tutorial of parasitology. And in last session we have seen the reproductive organs of the Taenia Solium. Okay, so in this session we will focus on the life cycle or the life history of this Taenia Solium. Okay. So we have seen the reproductive organs, the female as well as the male reproductive organs, okay. And now we are interested in the how this particular Taenia solium is a hermaphrodite animal, we know, and how this hermaphrodite parasite is going to complete its life journey towards the next generation. We will see how it going to complete its life cycle or the life history. Okay, so the copulation and fertilization in the Taenia solium. Okay, so the it is self fertilization occurs by the insertion of a cirrus of the proglottid into the vagina of the same proglottid, and sperms are deposited there. Okay, so as we all know, the hermaphrodite animal, okay, and it is self fertilization, nothing but the male and female reproductive organs are present in a particular that gravid proglottid. Okay, and that gravid proglottid segment having the male organs, okay, which we also know that the male is um, going to mature early than the female reproductive organs. Okay, hence the both reproductive systems are located in a same proglottid. So the male is going to mature first. Okay, then its sperms are going to stored in a sperm sac. Okay, and then that sperm sac are the sperms are going to release from that sperm sacs and um, going to enters in vagina, and then the uh, other functions or the rest of the processes are going to happen. Okay, from the vagina the sperm come to lie in the seminal receptacles. Okay, where they fertilize these eggs in the oviduct. Okay, so what happens, but some cross fertilization between different proglottid, okay, of the same tapeworm is very common. Okay, so the actually Taenia solium is a protandrous. Okay, protandrous means the testis matures first than the um, its ovaries. Okay, so hence after the copulation the sperms are stored temporarily in the seminal receptacles or the sperm sacs. Okay, and waiting for the maturity of the eggs. Okay, and then when such eggs come in contact or they are going to release from the oviduct, then and then this fertilization happens. Okay, and after this fertilization the eggs are transformed into capsules and packed in the uterus. Okay, where their latter the various reproductive organs degenerate and the uterus become the distinct and the branched, having more than 30,000 to 40,000 egg capsules. Okay, and that 30,000 to the 40,000 egg capsules, uh, just formation, how that egg capsules are get formed, we will look after it. Okay, so the just after fertilization the zygote gets surrounded by yolk in the ootyp. Okay, we have seen the where the junction of various systems, okay, that is the UTP, junction of the reproductive system, where uterus going to meet and the vagina going to meet. After that, the various glands are having its duct and way to the that particular UTP, okay. At that UTP, it receives from the vitelline gland, okay, and that vitelline gland or the vitelline duct, okay, and the zygote and the yolk then become enclosed in the thin shell or the chronic membrane, okay, and that chronic membrane which is formed from the yolk material, okay. So the structure thus formed is called capsule, which passes into the uterus, okay. So the section of a Mehlitz's gland facilitates the passage of a capsule in the uterus, okay. However, the gravid proglottid gets separated from the strobila, okay. Entire gravid proglottid going to separate, okay, and passes out with the fecus of the host, okay. So as you all know, the UTP, okay, let's see the UTP, okay, here, okay, as you can see the Mehlitz's gland, okay, that are uh, going to pass yolk into the that particular UTP, okay, and that seminal receptacles are going to invade and that are passed or the formation of the that particular facilitate the passage capsules are get formed over there, okay. So the development in the Taenia Solium, okay. So after the fertilization and after the formation of the egg capsules, there will be the stage that is known as the development of that capsules, okay. And how that capsules are going to get convert into a mature or the infant of this Taenia worm, okay. So it starts when the eggs entered the uterus, okay, and zygote first divides unequally to give rise a larger membrane and a smaller embryonic cell, okay. The megamere, that is the, as you can see the megamere, okay. So you see here the egg cell or the zygote, okay, and latter it is the megamere, okay. That zygote is going to enlarge, okay, by means of the proliferation, okay, and that yolk cells are nothing but to provide the nutritive material to the embryo that is going to um, cultured over there, okay. So the growing embryo and that embryonic cells, okay, the megamere means the large cell, okay, and the embryonic cell, the larger cell or the enlarged in the size is known as the megamere, okay. So the megamere divides a number of times to give rise a several similar megameres, okay. And similarly, the embryonic cell divides repeatedly, and that rapid divisions is gives rise to the two types of the cells in larger mesomeres and the smaller micromeres, okay. As you can see at the image D, okay, as you can see the multiple proliferation or the repetitive proliferation will lead to give rise to the mesomeres and the megameres, okay, and that micromeres, mesomeres and the megameres, okay. Micromeres means the very developing cells the minute cells. Okay, mesomeres means the at the middle range cells, and the megameres means the larger cells. Okay, so these, hence from the zygote, three types of the cells are resulted. Okay, that will be micromeres, mesomeres, and the megameres. Okay, so these are the larger megameres, medium size mesomeres, and the smaller are the micromeres, which are arranged in a characteristic sequence. Okay, so in fact, the smaller micromeres form a inner ball of a cell mass called as the morula. Okay, as you can see the image E. Okay, this that smaller micromeres are get converted into the morula. Okay, and the inner ball of cell mass called morula. Okay, the mesomeres are replaced or the placed as envelope around the morula, while the megameres has outer envelope around the mesomeres, as you can see the image E. Okay, so the inner part, that morula, is get formed by means of the micromeres. Okay, and the outer part, that is the embryophore secreting mesomeres. Okay, and morula is, you can see the yolk cells, as you can see the yolky membranes. Okay, and these are three types of the cells which are going to get convert afterwards into the mesomeres, megameres, and the micromeres to the next morula. Okay, the yolk cells and the embryonic secreting mesomeres. Okay, so the megameres after that, they fuse to form the outer embryonic membrane, which finally disappears. Okay, and this outer embryonic membrane, as you can see the border of this cell, is going to disappear. Okay, and the mesomeres from inner embryonic membrane to embryophore, which is thick, hard, cuticalized, and straightened. Okay, so the below the embryophore, a thin basement membrane is also formed. Okay, that thin basement membrane uh, is nothing but the inner cell mass of the morula, forms an embryo which develops the 6 chitinous hooks. Okay, and it deposited and posterior side. Okay, the hooks are secreted by some differentiated cells of morula called as the oncoblast. Okay, and then after this sixth hook embryo is called as the hexacanth. Okay, and which passes a pair of penetration glands. Okay, and it's surrounded by two hexacanth membrane. As you can see, this is the hexacanth. Okay, and as you can see the all the degeneration of the other materials into that particular um, segment, which are going to release by means of the fecuses, and after that these hexacanth formations is going to happen. Okay, where these embryos are going to get in the G0 stage. Okay, that means they are going to get into the hibernation. Okay, so the hexacanth embryo, and that is hexacanth membranes, basement membranes. Okay, the embryophore and the egg cell or the chronic membranes to get together. Okay, is known as the oncophore. Okay, the gravid proglottids which passes out from the host body and contains the embryos in the oncophore. Okay, so these hexacanths are nothing but the formations after the eggs. Okay, and that eggs after get fertilized. Okay, then that eggs are going to pack a um, certain way. Okay, and that certain way of packing and going to degeneration, that are nothing but the hexacanth of this particular Taenia Solium. Okay, where there that segment is going to pinch off and going to get pass by means of the that ficuses. Okay, and that after that going to pass that ficus, that are going to get convert into this hexacanth, and um, they are remaining over these G0 conditions up to the new host going to get in contact with that hexacanth. Okay, so we will stop here and we will continue this topic in the next session. Okay, thank you.